Hello, geometry students. We are going to start 13-1, representing sample spaces. So that's chapter 13, section 1. We're going to use tables and tree diagrams to represent possible outcomes in sample spaces in this video. So we're going to be able to understand sample spaces in this video. So here's some vocab words. If you are unfamiliar with them, go ahead and write these down. We did some background lessons in probability before this video. So an experiment is a situation involving chance that leads to a result called outcomes. In your book, at the beginning of this section, it gives an outcome of, or an example of tossing a coin. So that experiment would be tossing the coin. An outcome is a result of a single performance or trial of an experiment. So the possible outcomes would be landing on heads or tails. And an event is one or more outcomes of an experiment. So one event of the experiment is landing on tails. Now the sample space is the set of all possible outcomes of a random process. How do you define the random process? Determines the sample space and the number of possible outcomes. So we're going to do some examples so we understand this definition better. Suppose we are tossing two coins. Represent the sample space for this experiment by making a table and a tree diagram. So let's start with the table first. So here's the table. This column is going to be your first coin, and this will be your second coin. Okay. So our sample space, we could get heads and heads. We could get heads and tails. We could get tails and heads, or we could get tails and then tails. Okay. Now to represent this as a tree diagram, the first branches are going to be the first toss. So we could either get heads or tails. The second toss, excuse me, my thing is wigging out here. So the second toss could be either heads or tails for both. So then our sample space for just tossing two coins could be heads and heads, heads and tails, and I'm just going across here on the tree what I'm going to get. Tails and heads, come on, and then tails and tails. Okay. So notice the sample spaces look the same, they're just two different ways of representing them. Okay, and so the number of unique outcomes. Okay, so how many unique outcomes do we have here? We have 4 different unique outcomes. Okay, and they are equally likely to happen, right? There's 1 out of 4 shot that you could get these, so they are equally likely. All right. Now, if we change the random process. Right now the random process is just tossing 2 coins. So now our sample space and our possible outcomes are the same. If we were to change the random process to be the total number of heads when you toss 2 coins. Alright, so now we just want to know what the number of heads will be when flipping 2 coins. So now our sample space changes. Okay, now our sample space ends up being, okay, we could get 0. Okay, we could get 0. Here, I'll do another color. We could get 0 heads because again, it's the number of heads. So we could get 0. All right, we could get 1 here. We could get 1 here, or we could get 2. So now our sample space, the random process is the number of heads. So now our sample space looks like this. We could get 0, 1, or 2 heads. Okay. And so the number of unique outcomes, So the number of unique outcomes, okay, let me write this out, changes from 4, which we had earlier with the different random process. With just wanting heads, we could get 3. Okay, we could get, there's 3 different unique outcomes. Now, are they all equally likely? No. In this case, you could get 1 head. There's a greater chance of getting 1 head in this process. So they're not equally likely. Okay? Not equally likely. All right, just to keep that in mind. All right. Now, when rolling a 6-sided die, the sample space is 1, 2, 3, 4, 5, and 6. That's what you can get. In this case, each outcome is equally likely. For rolling 2 dice, the sample space varies depending on how the process is defined. So let's just find the possible outcomes for rolling 2 dice. So we're going to do what we did on the last example and go ahead and make a table. Alrighty, we're going to make a table. So this will be your first and this will be your second. So here you have 1, 1, 1, 2, and so on. So I want you to finish this table up. Okay, I want you to go ahead and pause the video and finish this table and see if you can do a tree diagram as well. Alright, so here's the table for the 2 dice. Okay, here's the table. And the tree diagram I went ahead and did. Now mine is not very good because of the program that I have. So, sorry, that's my daughter. She's playing downstairs. She's screaming. Okay, let's see here. So here would be my my tree diagram. I know it's not very good. Your guys' is better because you have more paper, more space to write. But there's the tree diagram. All right. So let's go back to our table and take a look at the unique outcomes. So how many unique outcomes do we have just for rolling 2 dice? Okay, how many unique outcomes? I'm trying to put this back because I don't want this yet. Right, we have 36. Okay, we have 36 unique outcomes. Now, are they all equally likely? Come on, stupid thing. Sorry. This is big now here. I haven't charged today. I'm at home here. All right, so I'm going to rewrite that. Hold on. Okay, so 36 unique outcomes, and they are all equally likely. Okay, they are all equally likely. Now, if we were to change our random process, let's find the sample space for the sum of rolling 2 dice. So the sum. So for the sums, we would, I'm going to get a new page here. We are going to add the 2 dice together. So go ahead and look at your sample space and add your values together and list them out in the sample space. All right, so what did we come up with? We're going to get 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that would be our sample space for just adding 2 dice. Now that's 11, okay, 11 unique outcomes. So we have 11 unique outcomes here. And are they equally likely? No, they're not equally likely. So they're not equally likely. All right. Because we have less chance of getting 12 and 2 than we would 7, right? And we're going to talk about that more in class. But I just wanted to give you a little background on sample space. Alrighty, so that's all I have for you. Feel free to write down questions and come with anything that you didn't understand. Come with questions over that. And I'll see you guys later. Adios.